I'm Emil. I'm also in apprenticeship. Yes. Auf Deutsch, ich bin Emil. Ich bin auch noch in der Ausbildung. Manche erkennt mich. Somebody knew me from the last Jungschmiede-Treffen in Hagen, from the last real Jungschmiede-Treffen, not internet Jungschmiede-Treffen. So I prepared a presentation about reduce carbon dioxide emission. I hope you see the right picture now. Let's start. You see the topic of presentation is innovation in our workshop. Why should we reduce our carbon dioxide emission while heating steel? There are three over topics why we should reduce carbon dioxide. The first is the public perception and health. It's if we burn coal, there's much respirable dust, and more people are sensible for emissions of carbon dioxide. There's an image of a blacksmith. It's from the mid-age and not anymore of modern trade. So we have the chance to change this image a little bit and get a modern craft and not anymore the blacksmiths on mid-age festivals or something. The last part is be responsible for our future. That's a modern topic because there are many reasons to do something to reduce carbon dioxide and other warming house gases. That's also the next big topic, ecology. Maybe you remember the climate conference in Paris. It's 5 years ago, and the European, not only European, the world, the most countries of the world said that they want to reduce heat trapping gases by 40%. And yes, we're not a really big part for this because there are not so much blacksmiths, but we also have a responsibility for the whole society. So we have to reduce this. Yes, that's for more than 5 years ago, and it's not happened that much. Next point is minimizing operation costs. I look for the coal forge and for an induction heater for the cost to heat one time 1 kilo of iron. To heat 1 kilo iron, you need 130 Wattstunden. I don't know in English. It's it's energy. So the coal forge has an efficiency from 6%. Induction heater has 70%. So you see it in decimal numbers. The induction heater, the efficiency is coupled to the material you will heat. So there's the steel behind the efficiency. So the energy you have to reach, you see the next line, and down you see the price it takes to heat the iron, 1 kilo iron. one time. It's only the heating. Only one heating. The induction heater takes no more energy if you're not heating. Your cold forge is burning while you're smithing the iron. You forge the iron. So there are more costs on it. So next point, how to reduce carbon dioxide. Yeah, the simplest is process heating. If you use a smaller fire or smaller forge, or sometimes only use the torch, you reduce the carbon dioxide emission because you don't use that much energy. The next point can be change your fuel. You see coal and gas. You see the efficiency. Efficiency is a little bit higher by gas. So and here you see the carbon dioxide emissions per one time heating 1 kilo steel. So it's lower by gas because gas is a little bit efficienter and has a lower emission than from carbon dioxide than coal. And the last point is use induction. The first point, we will look in which material we can use it. We can use induction with every electroconductive material. The only thing you have to watch is if you have a cardiac pacemaker, the induction will not destroy, but while you use the induction heater, the cardiac pacemaker can't work. So the efficiency is much higher. You see, this is the efficiency for steel. This line. Sorry, this line. It's from steel. So we have efficiency up to 70%, and that's much more than in a cold forge. So the next part is the physics behind induction. In every electroconductive material are free electrons. The induction heater produces a varying magnetic field. So the electrons get direction in the workpiece. So you have electrical current in the workpiece, and the metal, maybe iron, has an own resistant, electrical resistant, and through this resistant the heat comes. There's a question about efficiency for coal. I showed it's 6%, and for gas forge it is 10%.
My question is, I've been looking quite a bit at different machines. Can any of you in Europe recommend a manufacturer that isn't Chinese?
I can just say I've just bought a Chinese machine via Amazon, but there seems to be also some manufacturer in France, of which I give you the website and so. But I have not contacted themselves. I only contacted German people, and they didn't have anything.
I've looked at quite a few manufacturers, and there seems to be a huge discrepancy in cost. If you go to look at people that specialize in induction heating and forging, their machines seem to start at around £8,000 to £10,000. and but they look like they're, you know, high quality kit. All that's available to us, it seems, unless you want to spend that, are the Chinese imports, which seem to be quite low cost. And I'm just wondering on the durability of them in the long term. I don't know if anybody's had a lot of experience with them.
I would answer the question from Matteo Snape.
Yo.
The efficient studies about induction are really good because induction is often used in industrial, and so there's really good really good studies. The efficiency studies about gas and coal are not that much good. They are from my school books, and that's what we learned at school to figure out the needing of coal, the mass of needing coal, something. The next question is from Mariano. Is there a way to reduce the emission of gases in coal forge to interchase their performance? There are some ways we all know. Can you use, if you use less wind in your coal forge, you're burning less coal, so your emissions are also lower. So that's the point you can do. I didn't hear about to change anything on your forge to reduce it.
The other day, I remember, I think you, Patrick, told me that if you put water between the in the forge, you can high a little the temperature or something like that. I don't know if not only the shape of the forge, but maybe some kind of thing like that.
So there's always a way to reduce the smoke coming out of your forge. If at some point it increases the performance in efficiency, but in first case the gases that come off are way less aggressive and annoying to the user. And the trick is to build up your fire in 3 stages. So you got the coal, the fresh coal you use for forging that comes out of your bag. You pile it around around your fire, or make 2 mountains at the side. And so every time while your fire is burning, always there's some coal converting into coke around your fire. So all the impurities are burning off. Of course, there's some impurities that end up being in your slag, in your clinker at the bottom, but some impurities like Schwefel, maybe some German could translate this, are burning off. In this case, so there's way less smoke as if you put your coal right on top of the fire and let it convert into coke.
I can also suggest that you use a more efficient burner and only appropriate size burner to your chamber. How do you deal with the reducing section and the size of the coil, as this affects the efficiency? Emil, maybe you have some answer to that.
Probably not that specific, I fear. Yes, there's an effect to the efficiency if you use another coil, or a bigger or a smaller coil. There are much internet sites that are sites where you can calculate your effect of another coil of another frequency. There's a difference in the frequency. If you use lower frequencies, you get the workpiece more hot in the middle of the workpiece. If you use higher frequencies, the surface get more hot. So there are effects, but that's difficult to describe. There are some internet calculators who did this for you, and you can also calculate the temperature there, because if you know how much energy you give to your workpiece, you can calculate how much temperature your workpiece have after 2 minutes, after 4 minutes. So you can heat your material without a thermometer on the point.
Mariano, seem to maybe you have some kind of response directly to that.
Yes, I don't have the numbers, but changing the size of the coils is something you can hit the surface really fast, and you don't touch the center. This is the difference. When you change the size of the coil, the piece haven't time to heat entirely. So, for example, if you need temporary only the surface and you need the center soft, you can use, in this case, the right size of the coil. This is what you have when you change the size. And this is why it's important the right size and shape of the coil in this kind of machines.
Steve, does this answer your question? Maybe you can just talk to us.
Well, it does in a way, but my concern, interest, is that if you're forging a section down and you're reducing the size of it, if you started with a piece of, let's say, 30 diameter, and it was a good fit in the coil, and you reduce the section of it to say 16 millimeters, how does that affect the efficiency of the machine? Does it? Should you be going then to a smaller coil? I mean, because from what I've read, the efficiency of the machines is important, that the coils are a good fit to the material. So that's my question, really. And if you're using a coil for multiple sizes because to save changing them, how does this affect your machine itself, how it works or its life?
Maybe from what I've been hearing so far, I can answer your question in that way, that yes, there is a big effect. And I've been also watching several videos which show this. One video which I have shown had like 2 coils in one coil. There was like a bigger and a smaller wind out of the same material. It is though such that the maximum output from your machine dictates how big a mass you can heat and how much induction force you can create. Further practicalities, because I think not so many people here have an induction forge, are not yet known to the people here present.
I mean, you've answered my question in the fact that there's a few unknowns for the type of work that we produce, where often the work becomes different size. How the efficiency of the machine and how it affects it. If you're just heading bolts or rivets, you can use one coil and backwards and forwards, and it's highly efficient. But if you're shaping the material into a different size, I'm wondering, you know, are there machines that have two coils that you could switch one to the other that may suit our type of work? I don't know. I mean, they're a very efficient machine, and it seems it's a good way to go. But I don't think there's a machine on the market at the moment that really suits creative blacksmithing. Or I may be wrong. I don't know what others feel.
There's one answer in the chat which totally fits you, which I just read out. It would be useful to find machines with more than one coil holder to be able to have different coils and to be able to just switch between them and not have to change them. Perhaps something to look for in a good industrial machine.
I would say what would be a good idea as a whole group, you know, in Europe or America, is if we could find a manufacturer who would make something to suit our market, because I think there is a market there for it now and there's a more interest in it. There's industrially, they've been used for a long while, but the machines seem to me are made for specific jobs, repetition work. So I think there's an opening there for a company if there's enough products to be made. Have a conversation with a company in Europe somewhere that would listen to us and maybe tell us whether it was possible or not. China just seems such a long way away, and you're very unsure of the environmental standards everything's made under. You know, when you think of the carbon issues we're discussing.
Well, in probably about 1.5 months, I can tell you something, because I have a machine right behind me, which I cannot put into use because they delivered the wrong machine. It's so annoying. But you have indeed there a good point. Maybe some more people can have some practical experience, and maybe everyone who is interested in this kind of product can afterwards join this newsletter, this Schmiede newsletter, to receive it in future. And we will probably come as soon as there is something about this. We will come back, and I will use this. And we'll maybe use this as a platform to to spread this information.
It sounds good. You join the newsletter.
It just works on the same, like on this website. I just posted to the chat right now, and one can find it there in the bottom of the page. In the meantime, I would like, Emil, maybe you can read John Will's question and have some answer for that.
There's a formula for the power requirement to reach welding temperature based on the mass of the steel. Which are you heating, or kilograms per equal? Yes, there's a formula. That's the normal formula you use every time if you want to calculate Wärmemenge.
There's one, Ned Willett said that it's probably the main issue is the liquid cooler used, which is certainly true, because you have to then always unplug and stop the cooling and so on. Then Doug Eichert said there is also Induction Forging Facebook group as well. So for people who are on Facebook, this might be an option. Then again, Ned Willett, also there are in UK 2 companies I know which have the most experience using this are Phil Johnson and Co in Scotland, and they are very approachable about induction forges. Pretty cool to know. Maybe this answers also your question, Steve.
Yeah, okay, yeah, I know Pete, so I'll ask Pete and then I can feed back to you guys.
Amazing.
I'll do that. I'll ask him and give you what he says.
So, William, you have been also asking, are there efficiency numbers which you quoted referring to heating efficiency in terms of fuel usage relative to heating potential, or are they referring specifically to emissions?
You want to know the efficiency relative to the specific emissions. Here you can see it. You see the efficiency and the emission that we have for 1 kilogram steel.
And then there came from Paul Voss the question, how heavy should the electricity connection be? Is 3 times 25 amperes enough, or what would you suggest?
For Germany, I would say the normal Werkstattanschluss, the normal Starkstromanschluss is enough. That's in Germany, it's 400 volt per 16 amperes minimum. You can take bigger, but for normal induction forge, this is enough. 400 Ampere mal 16, 400 Volt mal 16 Ampere.
Yeah. So, and I have an addition to that. Most of the industrial machines, like run on, like which you can normally buy, need like high electricity, like high voltage,
Yes.
400 volt. But they're three-phase, yes. But the one I bought from China runs on single phase.
Nice. I don't know that.
So you could put it. You're supposed to plug it into a normal socket. Like, is your question answered, Paul?
Not really.
Okay.
But, I'll figure it out.
Maybe you can ask the question again then.
Well, you see often that you have 3 phases in workshops.
Yes.
And for instance, my power hammer works on power electricity, 3 phases, 3 times 25 amperes, and I've power enough to switch on other instruments. So my question is, can I use this low carbon electricity apparatus besides my power hammer, etc.?
I think a small one like Patrick bought now you can use.
Okay.
And the part is your power hammer you only use while you have heated steel, and if you're heating steel you don't use a power hammer.
Yes.
So you can work with if you need a bigger machine than Patrick's machine, you can heat and then go to the hammer.
But that's the situation when you work alone.
Yes, I know.
That someone is heating and someone is using the power.
I know.
You work, but no problem.
But I think for the most things that's enough for the small machines like Patrick's ones. It's enough. You can use it while you use your power hammer.
What is the usual connection in Germany when you have electricity in your workshop?
One phase electricity is 230 volts and 16 amperes, and the normal high voltage electricity is 400 volt and 16 amperes. But the most welding machines use double ampere numbers. So you have 32 amperes. That's also normally in Germany for Werkstattstrom.
Connected to this from Matthew, that the smallest machines like 15 kilowatt can run off single phase, but with 16 amperage supply, which is the same as you have in your kitchen probably.
Yes.
Or bigger ones need more amperage than 3 phase.
If you want to heat up a big billet, like if you want to make a by this type of hammer, or go some artistic work where you gotta heat like 40 millimeter square steel or bigger, it is possible with a induction heater, because the outer scale of your workpiece gets hot so much faster than the inside.
It was difficult to understand your question because of the connection of my computer.
Ich kann es auch auf Deutsch sagen. Also, wenn,
Yes, try it maybe. Also versuch das mal, vielleicht verstehe ich dann mehr aus dem Kontext heraus, aber irgendwie höre ich dich gerade sehr abgehackt. Das ist ein bisschen schwierig.
also meine Frage ist, wenn ich jetzt große Querschnitte auf dem Induktionsofen warm machen will, zum Beispiel 40 mm Vierkant oder größer, also plus, ob das möglich ist, dadurch, dass halt die äußeren Schichten vom Material so viel schneller erwärmt werden. Wie
ich antworte dem jetzt mal kurz auf Deutsch. Ich übersetze es auch, ich versuche es gleich zu übersetzen. Das hängt von der Frequenz ab. Du kannst, wenn du einen sehr niedrig, also du kannst auch auf so Internetberechnungsseiten berechnen, was die minimale Frequenz ist, die du brauchst. Und dann nimmst du auch diese minimale Frequenz, weil umso niedriger die Frequenz ist, umso eher hast du die Wirkung im Zentrum des Materials. Das mit dem Oberflächen Aufwärmen hast du mehr, wenn du hohe Frequenzen hast. So I tried to translate. He asked about the effect we talk through that the surface get hot or quicker hot than the middle of the material, and I answered that that's relative to the frequency you use, because the frequency has an effect to the warming of the surface of the middle of the workpiece. Steve, right, there is a design of the coil in the picture. Looked like it gives easy access to the work. Is it your design? No, it's not my design. It's from the, you mean, read this, I think?
Yes, that's.
It's not mine. It's from the internet site Induction Partners. It's a French site that they have a lot of know-how with induction heaters.
Okay, thank you.
If you're interested in induction, I really can suggest this internet site. I also write the link in the handout.
Okay, that sounds good. I'd be interested to have the link.
Well,
Yes.
there, in addition to that, there is also one, I think, American guy who has a taco-shaped coil, which basically has the same function.
Yes.
So-
The only you can form the coil like you want. The only thing that you have to think about is the coil. You can look in the internet how the magnetic field of a coil is built. So, and the workpiece had to be in the magnetic field of the coil. If it can't be in the magnetic field, your workpiece don't get warm.
Okay, that makes a lot of sense.
Great. To me, this looks like all the questions I've been seeing in the chat have been answered. There is one addition to Paul's from Net Village to Paul Voss's question. I think you could run both at once. It would not overload the three-phase supply. It's a very high capacity electricity supply. For example, we run 5 CNC machines at one time of our free phase.